Imagine you are given a question in this form. You have a point charge Q and a grounded conducting sphere with radius r are placed as shown in the diagram. In the Cartesian coordinates, the center of the sphere is at its origin, and the position of the point charges in this form, which is clearly stated on the diagram. And the first question, we are asked to find the potential at x, y, z outside the sphere. Then what is the potential outside the sphere? But before we solve this problem, there is something we need to keep in mind. One of the properties of a conductor is that the electric field E is equal to 0 inside the conductor. The reason is that when you have a conductor and there is an external force or external field, then the charge within the conductor will rearrange themselves in such a way that they will cancel the external field and maintain the field within the conductor to be 0. So, and this can be calculated mathematically, although it involves a long process. So the best way to do it is by using an image charge. When you have a charge, since you already know that there is a charge, there should be a charge inside this conductor that will cancel the effect of the field created by this charge. Then you are good to go. So let's assume, let me pick another color, blue. Let's assume the image charge is placed somewhere here. I have Q prime. But remember, this charge must be negative because this is positive. If this charge is negative, then it's expected to cancel out the field created by this. So assuming the distance from here to the center of the sphere is A, which is equal to 2r. A is equal to 2r. And the distance from the center to this point where we placed our image charge is B. Now, how can we calculate the potential? We know that the potential V is equal to one over 4 pi epsilon naught Q over R. So this is the potential. But in this case, we are having two charges. So we'll be having the V, the potential, to be equal to 1 over 4 pi epsilon naught. Then the potential for this charge will be Q divided by the square root of x squared plus y squared plus z minus a. Z minus a in the sense that the charge is placed along the z coordinate minus, now the potential for this part will be Q prime divided by the square root of x squared plus y squared plus z minus b square. The image charge Q is given out R over A Q, and this is equal to R divided by our A will be the distance from the middle, which is the center of the sphere, to this point, which is 2R Q. So the image charge will be equal to 1 over 2 Q. 1 over 2 Q. So this is the image charge. And we can as well get the distance from here, which is the center, to the image charge. B will be equal to R squared over A, and B is equal to R squared is okay, and A is 2R. So this will be equal to R over 2. So this expression represents the B. So if we decide to substitute A, B, and Q prime into this expression, then we'll be having that the potential V will be equal to Q over epsilon 4 pi epsilon naught into 1 divided by the square x squared plus y squared plus, here we are having this to be z minus a, and this will be equal to z minus 2r square minus 1 divided by this should be 1 over 2 divided by the square root of 1 over 2, in the sense that we got the Q prime, which is the image charge, to be half Q, and if we decide to substitute the Q prime and we eliminate the Q, sorry, we factor out Q rather, and this will be half at this place, and we have x squared plus y squared plus z minus b, when we got b to be equal to r over 2 squared, r over 2 squared. So if we decide to factor out a little, we'll be having q divided by 4 pi epsilon naught 1 divided by the square root of x squared plus y squared plus z minus 2r squared minus 1 divided by 2 the square root of x squared plus y squared plus z minus r over 2 square, and this is the potential. This is the potential. For the second part, we're told that an image charge q prime, let us introduce another point charge q prime to the system and place it at negative 4r. Find the q prime if the force on this point charge is 0. We should keep in mind of this, the force if this point charge is 0. Okay, to solve this, let's draw the diagram. Imagine this is the sphere, and we originally have a charge here, and these two are the distance q is 2r and is positive. This is the center with this, and we have the image charge q prime placed here. So we're told that another charge is placed in the negative direction with the distance 4r from the center. This is another charge q prime. The distance is 4r. Let me write the distance here. Q prime, and distance is 4r. Okay, we asked to find the force. We asked to find the charge q prime. Let's introduce this and place it there. Find the q prime if the force acting is 0. So if the force acting is 0. Okay, so for us now to complete this diagram, we need to place another image charge here, q. Let's assume we placed it probably somewhere 1 over 4 r. And we should keep in mind that we've already gotten q prime, this image charge, to be equal to r over a, and that is equal to raq rather is equal to r divided by 2r q, and this is equal to 1 over 2 r, 1 over 2 q. So we, from the Coulomb's law, we have that F is equal to 1 over 4 pi epsilon naught Q Q2 over R squared. So solving this, we have that F will be equal to Q prime divided by 4 pi epsilon naught into, then consider this distance from here to this point, that will be 6r. This will be q divided by 6r squared. Then if we consider the distance from here to the center, that is 4r, then we plus this distance as well, which that is minus, and we've gotten the q prime to be this 1/2 q divided by 4r plus half 1/2r squared, and this will be equal to minus the q prime 1/4 q prime divided by 4r minus 1/4 r squared is equal to 0. So simplifying this, then we can say that q divided by 6r squared is 36 r squared minus q into 2 in, then I have this 2 by 4 is 8 plus 1 is 9r divided by 2 all squared minus q prime divided by 4 into 4 by 4 is 16 minus 1, that's 15r divided by 4 all squared is equal to 0. Then we can decide to make q prime the subject formula. We can say that q prime divided by this is 4 into 15 square will be 225 r squared divided by 4 square is 16 is equal to q divided by 36 r squared minus q divided by 2 into 9 square is 81, and 81 r squared, and 2 square is 4. Simplifying further, we can say that this is q prime divided by 225 r squared divided by 4 is equal to q divided by 36 r squared minus q divided by 81 r squared minus 2. So, and this is equal to 4q prime divided by 225 r squared is equal to q divided by 36 r squared minus 2r divided by 81 r squared. At this point, you can factor out some things, and I have this to be 4q1 q prime divided by 225 r squared is equal to q divided by r squared into 1 divided by 36 minus 2 divided by 81. So at this point, r squared and r squared can cancel themselves, and I will be left with 4q prime divided by 225 is equal to Q, that is 81 minus 36 by 2 would be 72 divided by 36 by 30 by 81, and this will be equal to 4Q prime divided by 225 is equal to Q into 9 divided by 36 multiplied by 81, and I think 9 can cancel something here, then we'll be left with Q prime divided by 225 is equal to Q into 1 over 36 multiplied by 9. So at this point, we can decide to make Q prime the subject formula. Although, let me simplify it further a little. I have 225 is equal to Q divided by 36 by 9 will be 324. You can use your calculator. Then I can say that Q prime at this point is equal to 225 divided by 4 multiplied by 324 Q, and this is equal to have Q prime to be equal to 225 divided by 4 multiplied by 324 will be equal to 1296 Q, and if you divide this using your calculator, you'll be getting 0.1736 Q. So, and this is the final answer.